Okay, so our next topic is just factoring. Okay, so we spent like a week on this in class, and I want y'all to look over here on the left-hand side of your review, and I want you to just put some stars next to this. Always look for the greatest common factor first. We need to look for the GCF first. Okay, and that is no matter what type of quadratic we have. Okay, it can be 2 terms, it can be 3 terms, it can be 4 terms, but we always look for the GCF first. Okay, then, based on the number of terms, we can factor it in different ways. Okay, so we've got a couple of problems, 19 and 21. Okay, actually 19, 20, 21, and 22, they're very similar. All right, so let's start with number 19. Number 19 is basic, x squared minus 16. All right, so we look for GCF, and there's no GCF besides 1. Okay, and 1's not going to help us simplify this, so we'll just go ahead and we'll skip to our next step to factor something with 2 terms. And that's hopefully a difference of 2 squares. So factoring a difference of squares, we really just have to know the pattern. Okay, so the pattern is going to break down into 2 groups. Okay. All right, now inside these groups, we just have to put the square roots of these terms. And it kind of goes like this. We take the square root of the first term plus the square root of the last term, square root of the first term minus square root of the last term. And that's factored. Okay, so x plus 4, x minus 4. And if you switch those factors around, x minus 4 and then x plus 4, it means the same thing. Okay, so try number 20. Okay, so number 20, we have our 16x squared minus 36. And let's scoot this back over. Okay, so first, we need to look for a GCF. Okay, so between 16x squared and negative 36, is there a GCF? And yes, there is. We can divide 4 from both of those terms. Okay, so what we're going to do is we're going to pull this 4 out front, and we're going to divide 4 from each one of these numbers. 16 divided by 4 leaves me 4. The x squared is still there. Negative 36 divided by 4 is negative 9. And there we have factored it. But this is not the answer. Okay, we still have x squared, and anytime we see something squared, we need to ask ourselves, can this factor further? And yes, we have 2 terms. These 2 terms are perfect squares. There's a minus sign between them. This is a difference of 2 squares. Okay, so we're going to factor just this right here inside our group. We know it's a difference of squares, so we know it's going to break down into 2 groups. We know the factored form, because we remember the pattern, it's just the square root of the first term plus the square root of the last, the square root of the first, minus the square root of the last. Okay, now this 4, it stays in front of both of those factors. Okay, so let's write this out a little bit neater. We have 4, we have 2x plus 3, and we have 2x minus 3. And that is the full factored form of that problem. Okay, so number 21 is about the same. Okay, we've got the 4x squared minus 100. Okay, so again, we need to look for a GCF. Okay, and between 4x squared and negative 100, we can divide 4 from both of those terms. So 4 is going to come out front. Divide it from the first term, you're left with x squared. Divide 4 from the second term, you're left with minus 25. Okay, so we still have something squared, so this probably can factor one more time. And it's 2 terms. Both of these terms are perfect squares, meaning we can take the square root of them. So this is a difference of squares again. Okay, so the 4 is going to stay, and now we know this is going to break apart into 2 groups. Square root of the first term plus square root of the last, square root of the first term minus the square root of the last. And that is fully factored. Okay, so try 22. And let's see what we have. 49x squared minus 4y squared. Okay, so a lot of folks have trouble with this because it's got an extra variable in it, but it's the same problem. Okay, now we first look for a GCF, but between these two terms, all we can divide is 1. And 1's not going to help us simplify, so let's try to factor it as our other way to factor two terms, which is difference of squares. Okay, so 49x squared, that is a perfect square. Okay, we can take the square root of this, no problem. 4y squared, also, this is a perfect square. We take the square root of that, no problem. There's a minus sign between the two terms, so this is a difference of squares. We know how it factors. We remember the pattern. Two groups, square root of the first term, plus square root of the last term. Square root of the first term minus square root of the last term. And that is fully factored.